Hello all, today we're going to start chapter 2 and go through section 1 for GC111. So the first topic for this chapter is going to be functions. So we're going to talk about all different types of functions and what to do with them. So we're going to determine whether a relation represents a function. We're going to be able to find the value of a function, find the difference, the quotient of a function. We're going to look at the domain of the function by defined as an equation. We're also going to figure out the sum, the difference product of two different functions. So not just adding, the answers together, but adding actually and manipulating the actually two functions. So the first thing we're going to do is we need to determine whether a relation that we are given is going to represent an actual function. So here, let's look at this relation. We've got y equals 3x minus 1. That looks very odd. It should just be 3x. It should be 3x minus 1, but whatever, it's fine. So it represents a line, okay? We already looked at the y equals mx plus b, so we know the slope, we know the intercept, and that's how we get this line. So y equals mx plus b, just as a refresher. So your b is the intercept, and your m is the slope. So our intercept is here, and we go rise over run, 3 over 1. And that's how we connect those two dots in a straight line, and that's how we get that line. Now, some things that we can look at as functions are things such as animal life expectancy and possibly phone numbers. So are these a function? A function means that there is a one-to-one correlation between an x and a y. Okay, so for here, let's look at animal life expectancy, and we see a dog, a duck, a kangaroo, and a rabbit. So a dog and a kangaroo both have life expectancy of about 11 years, a duck 10, rabbit 7. So each one of the animals has a unique life expectancy. Now, on the other hand, if we look at phone numbers, we've got Dan and Gizmo, Colleen and Phoebe. Well, Colleen here apparently has multiple phone numbers. So she actually has 2. So the person in this case of Dan, Gizmo, Colleen, and Phoebe is not a function because of Colleen having 2 different phone numbers. Remember, it needs to be a 1-to-1. This one right here, it's a 1-to-1. This one right here, we've got a 1-to-2 with Colleen. So Colleen goes and messes up everything. So let's look at what the actual definition of a function is. So let x and y be 2 non-empty sets. So x and y are 2 things, okay, can't be empty. And a function from x to y is a relation that associates with each element of x exactly, and that's the word, that's their keyword here, exactly one element of y, okay? So for x, there is one and only one y. So when we go back to our rabbits and our people, if I say that these are the x's and these are the y's, you can see there is only one here, okay? Each one has only one answer of life expectancy. Now this over here, because of Colleen goes and screws everything up. Colleen has 2. That's what makes it not a function, okay? So for every x, there has to be exactly one y. Colleen here as an x has 2 y's. That's what makes it not able to be a function. Okay, so let's look at a quick example. So determine if the relation is a function. So state the domain and range, and then determine whether the relation is a function or not. For this relation, the input is the number of calories in a fast food sandwich, and the output is the fat content. So our number of calories is going to be our input. So let's look here and make an indication. Those are going to be what we're actually looking at. So the domain is going to be equal to, okay, we're going to put those curly brackets. And typically when we do the domain, we do put them in order. So the lowest one is 541. And then the next one up is 550. and then 580, and then 650, and then 700. Okay. So the domain is going to be your calories. Okay. Now, the range, on the other hand, is going to be your fat content. So your range is going to look like, with the curly brackets, and again, we like to put them in order, so let's go 29, 31, 33, 37, 43. Okay. So is this a function? Okay, well, we said a function has one value for y for every x, and this has each one of the calories has one and only one fat content. So we don't have two Wendy's singles with two different fat contents. So the answer is yes, it is a function. Okay, again, let's look at another example. So state the domain and range and determine whether the relation is a function. For this relation, the input are gasoline stations and the outputs are the price per gallon. So we can look at it in that way. So my domain is going to be the gas stations. Now, remember I said we put them in numerical order? Well, if it's a word, we can't put it in numerical order. So we put it in alphabetical order. So Citgo first, then Shell, then Texaco, and then Valero. Okay. Your range is going to be what then? So your range is going to be the Y, right? Now this we can put back in numerical order. Now, if you look at the range, there's one that's used twice. Well, in the range, we only list it once though. So let's start, we're going to go 319, 329, and 335. Okay, so that's the range. Now, is it a function? Well, for each one of our x, we only have y. It's okay that two of them share the same y. We cannot share the same x. Okay, that's the difference. So yes, it is a function. So one more example here. State the domain and range. So for the input, the weight in carats, so this is our x, and our output is the y. Remember, x is the input, y is the output. So our domain is going to be the x's, so 0.70, 0.71, 0.75. They're getting nice and smart with us and putting them in order for us. I'm very grateful. I don't have to think as much. And then the range is going to be equal to what's in the y. Okay, so let's start out with 1529, 1575, 1765, 1798, and 1952. Okay, so is this a function? Well, remember, for every x, we can only have y. What's going on here? So for this one, we've got two different y's. So the answer is no. So if I have a 0.71 carat diamond, pear cut diamond, my price can either be 1575 or 1925. I'll take the cheaper one, but that's okay. But that is what, in essence, makes it not a function, is the fact that it has two different prices associated with it. Okay, now for each relation, domain and range. So here, instead of having them in the graphical way, we've got them actually in XY pairs. So our X is going to be our domain, right? Which is going to be what? I can read my X's going across. So 1, 2, 3, 4. Okay, the y is the range, and that's going to be 4, 5, 6, 7. And again, they were nice. They put them in order for us. So, is it a function? If it's a function, really, we only have to look at the x's. Are any of the x's repeated? No, they're not. So then, yes, it's a function. There's only unique x's, okay? That is what is going to make it a function. Let's do another one with the ordered pairs. So x is the domain. Okay, here we've got 1, 2, 3, 6. And our y equals the range. And we've got 4. There's another 4, but we don't have to put it twice. 5 and 10. Is it a function? Okay, let's look at our x's. A 1, a 2, a 3, and a 6. Are any of them duplicated? No, they're all unique, so therefore it is a function. Okay, remember, the repeated y doesn't matter. We're only looking at x's for this. Let's do one last one in this way. So my domain is the x's. So let's go -3, -2, 0, 1, and we have a -3 again, but I already wrote it. Okay, so it's -3, -2, 0, 1. The range is going to be, we didn't put these in order. Great. 0, 1, 4, 8, and 9. And I believe I got everybody. 9, 4, 0, 1, 8. Beautimous. Okay, big question of the day, is it a function? Let's look at our x's. -3, -2, 0, 1. We have a repeated x. Since x is repeated, it's not a function. Okay, again, it's the x repeating, not the y. Okay, let's expand this one more time. Let's look at a function, an actual equation, and determine whether this equation defines y as a function of x. Okay, so in order to do that, we want to, number one, we want to solve for y. Okay, and find out what that looks like. So here we've got x squared minus 1 equals y squared. I literally just flip-flopped these suckers. Okay, so it's going to be a minus y squared. I just moved them around. I also can just take this sucker and put it here. So let's try that one. Y squared equals 1 minus x squared. That looks a little better. Let's use that one. They both mean the same. It's fine. Okay, so now what we need to find is what y is, though. So let's take some square roots. Okay, so now we get y equals plus or minus the square root of 1 minus x squared. Okay, so remember, y is going to be your output. So for values of x between -1 and -1, okay, there are going to be 2 values of y. Okay, why? Because let's look at, that has to be a positive number, right? So, for example, let's say x equals 0, y equals plus or minus square root of 1 minus 0. So y is going to be equal to plus or minus 1. Okay? Does that make sense? So there are 2 outputs of y for one x. Remember I said x and y. So my pairs are going to be 0, 1 and 0, -1. So if I look at the x's, I have a duplicate. So it's not a function. let's move on to the next topic. Let's find the value of a function. So a function, in essence, is an input-output machine. You're going to put in something for x, it's going to do something, and it's going to give you an output, or the y, or the function of x. You can look at it both the same way. So some functions that we've seen, f of x equals x squared, or y equals x squared. Remember, it can be y equals or a function of x. So for b, we've got f of x is 1 over x. You can see that there, again, there's always only one when we're looking at the x's. That is what's creating them and indicating that they are functions, okay? It does not matter what's on the y side, okay? Doesn't really matter. It could be one, it could be many, doesn't matter. It's what is happening on the x. For the x, there's one and only one answer and one output y. So let's look at how we do this evaluation, okay? So we're going to have an equation and we're going to see some different expressions, and let's see what they look like. So here our function is going to be f of x equals 2x squared. I believe that's supposed to be squared. Minus 3x, okay? Now, f of 3 means I put 3 in for x. So this is going to be 2 times 3 squared minus 3 times 3. Okay? So that is going to be 2 times 9 minus 3 times 3, 9. 18 minus 9 equals 9. Okay? F of x plus f of 3. So f of x is going to be 2x squared minus 3x plus 9. Okay? Because this part right here came from that, and this part right here came from that. So the next one I have is I want to multiply f of 3, which is 9, times 3, 27. So f of minus x. So we want to replace x with a minus x. So 2 times minus x squared minus 3 times minus x. Okay, so minus x squared and an x squared is going to give me the same thing. So that's going to be 2x squared. Now, this is going to give me a 3x, but it's going to give me a minus 3x, and a minus, and a minus is going to give me a plus 3x. Okay? Now, a minus f of x, that is just taking f of x, so 2x squared minus 3x, and putting a minus in front of it, okay? So that's going to give me a different answer of minus 2x squared plus 3x. I'm just going to take that and distribute it to each one. Okay? For this next one, f of 3x, I put the value of 3x in for x. So 2 times 3x squared minus 3 times 3x. Okay? So I'm going to have 2 times, I can take the squared and give it to both. So 3 squared, x squared, minus 3 times 3, 9x. Okay? So then I've got 2 times 9x squared minus 9x. That's going to give me 18x squared minus 9x. Last but not least, put in x plus 3 for the value of x. So 2 times x plus 3 squared minus 3 times x plus 3. Okay. So really all you're doing is you're taking whatever's in the parentheses and putting it in for x. Okay. So what you can do, so x plus 3 squared is going to give me what? X squared plus 3x plus 3x plus 9. And all of that times a 2, right, from up here. Remember, 2x squared plus, let's see, 3x and 3x is 6x. 6x times 2 is 12x plus 18 minus 3x minus 9 from that. Okay. Now let's put everything together that kind of matches. So I have a 2x squared. I've got that one and that one. So 12 minus 3 is 9 plus 9x. Then I have an 18 and a minus 9. So it's going to be a plus 9. So there's my final answer on that one. Okay. So that's basically how you find the values of a function. You take whatever's in those parentheses, and whatever it is, doesn't matter. It could be different letters, different numbers. It could add and subtract. It doesn't matter. Take that and put it in for the value of x. Now, how are we going to find the difference quotient of a function? Well, first of all, let's define what that means. So the difference quotient of a function of f at any x is given by f of x plus h minus f of x over h. Now, if you notice, it is a fraction, which means one thing: the denominator cannot be equal to 0. So we need to make sure that h is not equal to 0 in this equation. Now, it's going to be a little bit easier to go ahead and just do an example, and you'll see what I mean. But we have to remember f of x plus h minus f of x over h. So find the difference quotient of each function. So our first function is going to be 2x minus 3. So the first thing we do is we take our difference quotient function here. Now, remember what I said, we take whatever's in the parentheses and we put it in for x. So let's first find f of x plus h. So f of x plus h is going to be equal to 2 times x plus h squared minus 3 times x plus h. Okay, this looks really familiar to the one that we just did, so I'm going to cheat a little bit and go back. It's just like this one, right? But let's go back. So we've got x plus h squared times 2. So that gives x squared plus 2h x plus h squared times 2 plus 2xh plus, oops, 2, that's a 4, sorry, plus 2h squared, I forgot my square, minus 3x minus 3h. Okay. Now, remember what our equation is. So now what we want to subtract from it is the f of x. So let's say we've got 2x squared minus 3x. I'm going to put my like terms together, plus 4xh, right? Plus 2h squared minus 3h. Okay? And from all of that, I want to subtract 2x squared minus 3x. Okay? Well, I've got that here, and I've got that here, so I can get rid of that. So now what I've got is h squared, 2h squared, minus 3h plus 4xh. Now don't forget to divide it by h. I can pull h out of the top, right? Because every single term has an h. So I can say 2h minus 3 plus 4x. And those cancel out. So that's going to be equal to 4x plus 2h minus 3. Okay, that's the difference quotient. Take it baby steps. So the first thing I did was I figured out this. The second thing I did was that. Then the third thing I did was divide. Baby steps. Okay, let's do another one. So here is my function. So first, let's do the f of x plus h equals 4 over x plus h, right? Because you just put that in for x. Okay, so step 2, I'm going to subtract f of x. So 4 over x plus h minus 4 over x. Okay. The third thing I'm going to do is I'm going to divide it by h. 4 over x plus h minus 4 over x divided by h. Now let's take a look at that numerator and try and make it a little bit prettier. So x plus h minus 4 over x. Now I can multiply both sides by x plus h. That gets rid of that one. Then I can multiply both sides by x. And that gets rid of that one. So that gives me a numerator of 4x minus 4 times x plus h divided by h. Oh, let's see what that looks like. So 4x minus 4x minus 4h. We're going to put that, we're going to distribute that all over h. Well, we have a plus 4 and a minus 4, so those go away. So we end up with a minus 4h over h. So my answer is actually going to be minus 4. Step by step, baby steps. Okay. One last one of this type, and then we'll go on to the next topic. So find the difference quotient of this function. So this is the square root of x. It was as good as I could get it in the slides. I apologize. So f of x plus h is equal to square root of x plus h. Okay, that's step 1. Step 2, let's subtract. So square root of x plus h minus the square root of x. Step 3, and I'm just going to leave it ugly, x plus h minus square root of x over h. Okay. I'm just going to leave it like that. There's not really a whole lot we can do to make it better. Please don't freak out when you see square roots. It's just another thing. Okay, let's find the domain of a function defined by an equation. So again, the easiest way, let's look at an example first, and then we'll go into the definition. So find the domain of each of the following functions. Where are all of my symbols? So this is supposed to be f of x equals h of t equals g of x equals and f of x equals. Well, that's rude. I'm just going to make pluses. How's that? Oh, and it's a function. I don't know why it's not coming across on here. Okay, this is actually supposed to be minus. Let's see, plus minus over here, and this one's going to be a minus. So find the domain. So for a, let's look at this first one, a here. The function says to square a number and then add 5. So what could we do this on? We can do this on any number. There is no restriction on that. It's like it can't not be 0. It can't be, it's not that it can't be negative. So the function of this domain is all real numbers. Okay. Look at B here, though, on the other hand. So we've got B, and the biggest thing about B is that if you look at it, this denominator cannot be equal to 0, okay? So x squared minus 4 cannot be equal to 0. So x minus 2 cannot be equal to 0, okay? So this domain is x such that, whoops, such that x cannot equal plus or minus 2, okay? Because plus or minus 2 comes from here. Cannot be equal to 0 because it is in the denominator. Let's look at C here. So what are our rules about square roots? Our square roots cannot be negative. So it's valid for only when it's positive. So 4 minus 3t must be greater than or equal to 0. Okay, so let's solve for t. So minus 3t must be greater than or equal to 0. Oops, that's not 0. Minus 4. Divide by 3. Divide by minus 3. Oops. Man, my writing's getting terrible. So my t has got to be less than or equal to 4 over 3, or 1 1/3. So the domain on this one is all t's from infinity, negative infinity, to 4/3. Okay, because that's how we're going to do that. It's negative infinity to 4/3. Okay, let's look at D here. Now, this one has two parts, right? Part 1, part 2. So let's look at the bottom first. This cannot equal 0. So x cannot equal 5. That's part of it. Okay. Now let's look at the top. 3x plus 12 has to be greater than or equal to 0. So 3x has to be greater than or equal to negative 12. X has to be greater than or equal to negative 4. Now we combine these two, okay? So your domain is going to be equal to all x's such that x is greater than or equal to negative 4 and x is not equal to 5, okay? So to find the domain of the function, you just look at where that function is going to be valid for. Okay, so let's look at the actual definition now. So first, we're going to start with the domain as the set of all real numbers, and then we're going to find where it's not applicable. So if the equation has a denominator, that denominator cannot be equal to 0. And if the equation has a square root of some sort, we have to make sure that we're not taking the square root of a negative. The square root of a negative is imaginary, it doesn't exist. So that's what we have to do moving forward with that. So the little backwards showed you an example first, and then we went to definition, but hopefully you understand the final concept. So let's move on to the next, and it's the form, the sum, difference, product, and quotient of two functions. So let's look at the definition first. If f and g are functions, the sum of f plus g is the function defined by f of g plus f plus g of x equals f of x plus g of x, okay? So now notice where that addition sign is. It's in the function portion, not the variable portion. The x is the variable, the f is the function. The same thing happens with the difference. So if I want the difference of two functions and subtract them, it's just going to be subtracting the two functions. If I want the product, I just multiply. And if I want the quotient, I just divide. Now, again, quotient, we have to be careful, making sure that our g of x cannot be equal to 0 because we are having a denominator there. So let's look at an example. And of course, my symbols are missing for some reason. So f of x and g of x equals x minus 1, and x plus 2. So let the following functions determine the domain in each case. So let's do f plus g of x. Okay. From the definition we just saw, it is just equal to f of x plus g of x. Okay, so we have 1 over x plus 2 plus x over x minus 1. Now we can get rid of those denominators by doing our cross multiply. Plus x times x plus 2. Let's distribute. X minus 1 plus x squared plus 2x. Let's combine. Okay, so we have x squared plus 3x minus 1. Okay, now that's what the function is. Now let's figure out where, oh, sorry, this is x plus 2 over x minus 1. Okay, now where is that not valid? That's not valid where that bottom is equal to 0. Okay, so x plus 2 times x minus 1 cannot equal 0 because it's on the bottom. Now, anything multiplied by a 0 is 0. So either that has to be 0 or that cannot be 0. So for the first one, x cannot be equal to minus 2. And for the second one, x cannot be equal to 1. Okay. So the final answer for the domain is all x's, so that x is not equal to minus 2 and x is not equal to 1. Now, one thing to notice is that, so the domain here is x, such that x cannot be equal to minus 2. And the domain here is x, such that x cannot be equal to 1. So we took this domain and that domain, and that's what our final domain is of the two added together. So it's something that you might be able to take a look at. Let me put all my things back here because I don't know what happened. Udemys. Now let's subtract them and see what happens. Now remember again, this domain is all x, such that x cannot be equal to minus 2. This domain is all x, such that x cannot be equal to 1, because we can't have these bottoms be 0. Okay. Now let's subtract them. So I've got 1 over x plus 2 minus x over x minus 1. Okay. Let's subtract those two functions. Let's see what we get. Let's do the cross multiply. So we have x minus 1 minus x times x plus 2 over x plus 2, x minus 1. Let's do our little distribute. Minus x squared minus 2x all over x minus 1. Okay, let's combine some of those terms. So minus 2x and a plus x is going to give me a minus x squared minus x minus 1. Okay, over x plus 2. We could take a negative sign out. Negative x squared plus x plus 1 all over x plus 2, x minus 1. Okay, so one thing we need to notice again, remember denominator cannot be equal to 0, which gives us that domain again. X cannot be equal to minus 2, and x cannot be equal to 1. Oops, curly brackets. Let's multiply. Okay. Minus, plus. Okay, so what we're going to do is we're going to multiply the two together. And remember, domains haven't changed of f and g. They're the same thing. So 1 over x plus 2 times x over x minus 1. That's just going to give us x over x plus 2, x minus 1, right? Multiply, we just multiply straight across. This bottom cannot be equal to 0. So my domain, surprise, surprise, because it's been the same the whole time. X cannot be equal to minus 2. X cannot be equal to 1. Again, nothing has changed. And let's go through the last one. The last one is going to be division. F of x equals plus g of x equals minus. There we go. So I want to do 1 over x plus 2 divided by x over x plus 1. It's supposed to be minus. Sorry, x minus 1. Now, when we divide a fraction, we flip and multiply. So this is going to give us 1 over x plus 2 times x minus 1 over x. Okay, and then just carry that across. Now we may have something a little different going on, okay? So now this numerator, or the denominator, I'm sorry, cannot be equal to 0. So x cannot be equal to 0 because that's a piece of it, and x cannot be equal to minus 2. Okay. Now, there was one other caveat. Remember, g of x could not be equal to 0. So g of x equals 0 when x equals 0. So we need to add that in there too. Already there though. But g of x is undefined when x equals 1. So we need to add that one. Okay, so your domain is going to be on all x's such that x cannot be equal to minus 2, x cannot be equal to 0, and x cannot be equal to 1. Okay, so you've got the combo, g of x by itself. So the biggest thing to take away from this is that you need to look at the domains of each of the functions in particular, especially when you're doing the division, to make sure that that is a valid answer. So for the division, you need to do one extra step, and that's making sure that that g of x is defined and not equal to 0. So hopefully that goes into functions a little bit more and how to work with them. Again, if you have any questions, please email our professor, and I will see you next time.